Right now, as you're hearing this, there is a faint hum surrounding you. It's in every room, every city, every corner of every continent. It fills the space between galaxies. It's everywhere. And it's the oldest sound in existence, a whisper left over from the moment the universe was born. 13.8 billion years ago, everything you've ever seen, every star, every planet, every atom in your body did not exist. There was no space. There was no time. There was nothing. And then, somehow, from that nothing came absolutely everything. This is that story. And I don't just mean the textbook version. I mean the version where we've literally just, in the last few months, rewritten parts of it. Where telescopes are showing us things we were told couldn't exist. Where scientists in a lab in Cambridge may have found the actual molecule that started life. And where, for the first time in human history, a gene therapy designed to reverse aging is being injected into real human patients. The story of the universe isn't just ancient history. It's happening right now, and it's moving faster than ever. So, let's go back, all the way back to the very beginning. 13.8 billion years ago, give or take about 21 million years, something happened. We call it the Big Bang, which, by the way, was meant as an insult. A British astronomer named Fred Hoyle coined that term during a BBC radio broadcast in 1949 because he thought the idea was ridiculous. He believed the universe had always existed, no beginning, no end, just an eternal steady state. And honestly, that's kind of a reasonable thing to think, right? But the universe didn't care about Fred Hoyle's opinion. Here's what actually happened. In the first fraction of a second, a time period so small that more of them fit inside a single second than there are seconds in the entire age of the universe, everything we know, all the forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, they were all unified, merged into one. Physics, as we understand it, completely breaks down at this point. We literally don't have the math to describe it. Our two best theories, general relativity and quantum mechanics, they contradict each other at that scale. It's like asking what's north of the North Pole. The question doesn't quite work. But then something extraordinary happened. The universe began to inflate. Not like a balloon slowly filling with air, more like a balloon that doubles in size 90 times over in less than 1/1000th of a trillionth of a second, faster than the speed of light. And before you say, wait, nothing can travel faster than light, you're right, nothing moving through space can. But space itself? Space can stretch as fast as it wants. And it did. Now, here's where it gets wild. Within just 1 second, one single second, protons and neutrons had formed. And by the 3-minute mark, the universe had cooled to about 1 billion degrees and nuclear fusion kicked in. Protons and neutrons started slamming together, forging the first atomic nuclei, hydrogen and helium, roughly 3 parts hydrogen to 1 part helium. And here's the thing that blows my mind. That ratio, that recipe from the first 3 minutes of existence? It's still roughly the same today, 13.8 billion years later, and the universe is still running on that original recipe. But there were no atoms yet. The universe was too hot. Electrons couldn't settle into orbit around nuclei. Everything was just this screaming hot soup of charged particles, so dense that light couldn't travel through it. The universe was opaque. Imagine a fog so thick that a photon couldn't travel more than a tiny distance before bouncing off something. That went on for 380,000 years. And then the fog lifted. The universe cooled to around 3,000 degrees, and for the first time, electrons latched onto nuclei. Atoms were born. Hydrogen, helium. And with that, light was suddenly free. Photons that had been trapped for hundreds of thousands of years were released in every direction at once. That light is still traveling. It's still out there. And we found it. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were working at Bell Labs in New Jersey with a 20-foot horn-shaped antenna, and they kept picking up this annoying background hiss. It was coming from every direction. They couldn't explain it. They even climbed inside the antenna and cleaned out a bird's nest, thinking maybe that was causing the interference. It wasn't. What they'd stumbled on, completely by accident, was the cosmic microwave background, the afterglow of the Big Bang itself. That first light, now cooled to just 2.7 degrees above absolute zero. They won the Nobel Prize for it in 1978. And the kicker, a team at Princeton, just down the road, was literally building a telescope to find this exact signal. They got scooped by two guys cleaning pigeon droppings off an antenna. Science is beautiful that way. But here's the twist. That discovery proved the Big Bang happened. It killed the steady-state theory overnight. But it also opened up the biggest mystery in all of physics. Because when scientists looked at what the universe is actually made of, they found something deeply unsettling. Everything we can see, every star, every galaxy, every planet, you, me, the device you're watching this on, all of it makes up less than 5% of the universe. 5%. The rest? About 27% is something called dark matter, which we've never seen, never touched, and can't detect with any instrument. But we know it's there because galaxies would fly apart without it. Fritz Zwicky figured that out all the way back in 1933. And the remaining 68%? That's dark energy, the thing that's pushing the universe apart faster and faster, and we have absolutely no idea what it is. 95% of reality is invisible to us. Let that settle in for a second. And yet, somehow, from that 5% of visible matter, the universe built everything. After the first light was released, the cosmos entered what scientists call the Dark Ages, hundreds of millions of years of cold, silent darkness. No stars, no galaxies, just vast clouds of hydrogen drifting through an expanding void. And then, somewhere around 200 to 400 million years after the Big Bang, gravity started pulling those clouds together, compressing them, heating them, until something ignited. The first stars were born, cosmic dawn. These weren't stars like our sun. They were enormous, hundreds of times more massive, blazing hot, and they burned through their fuel in just a few million years before exploding as supernovae, scattering heavier elements, carbon, oxygen, nitrogen, iron, into the surrounding gas. And this is genuinely one of the most poetic things in all of science. Every heavy element in your body, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, was forged inside a star that died billions of years before our sun was even born. You are, quite literally, made of stardust. That's not a metaphor, that's chemistry. Now, in April of this year, 10 undergraduate students at the University of Chicago, as a class project, found one of the oldest stars ever discovered. It's called SDSSJ, 0715-7334. I know they really need to work on the naming. But this star is almost entirely hydrogen and helium, less than 0.005% of the metals found in our Sun. It's so chemically primitive that it likely formed near the very dawn of the universe. And the incredible part, it wasn't even born in our galaxy. It migrated here from the Large Magellanic Cloud billions of years ago. Professor Alex G. called it an ancient immigrant. And it's giving us an unprecedented look at what conditions were like at the very beginning. Meanwhile, the James Webb Space Telescope has been rewriting the rules. In January, it confirmed a galaxy called MOM Z14 as the most distant galaxy ever detected. We're seeing it as it was just 280 million years after the Big Bang, when the universe was about 2% of its current age. And here's the problem. It's too bright, too chemically enriched, too mature. It shouldn't exist that early. As MIT astronomer Rohan Naidu put it, it looks nothing like what we predicted. And that's what makes science so thrilling. The universe keeps surprising us. And then, just this month, the JWST's largest survey, called Cosmos Web, produced the most detailed map ever of the cosmic web, the vast skeleton of filaments and clusters that connects every galaxy in the universe. They analyzed over 164,000 galaxies, tracing this cosmic architecture back 13.7 billion years. We can now see the web of creation back to when the universe was only 1 billion years old, a structure that was essentially invisible before. At the same time, the Dark Energy Spectroscopic Instrument, DESI, completed the largest 3D map of the universe ever made. 47 million galaxies and quasars mapped across 11 billion years of cosmic history. And the early results are hinting at something that could change everything. Dark energy, the force that makes up 68% of the universe and that we always assumed was constant, might actually be weakening. It might be evolving over time. And if that's true, a physicist at Cornell has calculated that the universe might not expand forever. Instead, it could reach its maximum size in about 11 billion years, and then start collapsing, ending in what's called a big crunch roughly 20 billion years from now. The universe might have a shelf life. But let's not stop at structure. Let's talk about something even more mind-bending. How did chemistry become life? In February of this year, a team at the MRC Laboratory of Molecular Biology in Cambridge, the same lab where DNA's structure was first discovered, found a tiny RNA molecule called QT45. It's only 45 nucleotides long, and it can do something astonishing. It can copy itself and its complementary strand. That might sound small, but it's actually one of the most important discoveries in the origin of life field. Because the RNA world hypothesis, the leading idea about how life started, has always had a problem. The RNA, molecules that could copy other RNA, were always too big and too complex to have emerged spontaneously on the early Earth. QT45 changes that. It's small enough that it could plausibly have appeared naturally in a prebiotic soup billions of years ago. As lead researcher Edoardo Gianni put it, this makes the whole idea that self-replicating RNA emerged spontaneously much more likely. Think about that. Chemistry learned to copy itself. And from that one trick, everything we call life followed. Every tree, every fish, every civilization. All of it traces back to a molecule that figured out how to make a copy. And here's where the universe gets almost suspiciously well designed. A study this month from Queen Mary University of London found that the fundamental constants of the universe, things like the Planck constant and the charge of an electron, sit in an incredibly narrow window. Change them by even a few percent, and liquids wouldn't flow the way living cells need them to. Your blood would be too thick or too thin to function. The universe didn't just produce life. It seems almost calibrated for it. Now, let's bring this full circle, because here's what's happening right now in our lifetime that I think is the most extraordinary part of this entire story. Humans aren't just understanding the universe anymore. We're starting to hack it. At the same time, artificial intelligence isn't just helping scientists anymore. It's doing the science. Isomorphic Labs, the biotech company spun out of Google DeepMind, had their AI-designed cancer drug cleared by the FDA for human trials in January. The same technology that won Demis Hassabis a share of the 2024 Nobel Prize in Chemistry for predicting protein structures, is now designing entirely new drugs from scratch. Drugs that target molecular interactions human researchers hadn't even been looking at. The company raised $2.1 billion this month alone. We're watching the birth of a new era where artificial intelligence doesn't just assist discovery, it drives it. So step back for a second and take in the full picture. 13.8 billion years ago, there was nothing. No space, no time, no matter. And then, in a fraction of a second, something ignited. The universe inflated, cooled, forged its first atoms in 3 minutes, spent 380,000 years shrouded in fog, then released its first light. Stars ignited and died, scattering the elements that would become planets and people. Gravity wove it all into a cosmic web of filaments stretching billions of light years. Chemistry learned to copy itself. Life emerged. Consciousness arose. And now, here we are, atoms that learned how to think, building telescopes to look back at our own origin, and engineering therapies to rewrite the code of aging. From nothing to everything. And we're still just getting started. If this video made you see the universe a little differently, hit subscribe. I make videos like this every week, breaking down the biggest discoveries in science and space with real data. No fluff, just wonder. Drop a comment and tell me, what part of this story blows your mind the most? The fact that the universe might collapse? That students found one of the oldest stars from a classroom? Or that we're literally injecting people with therapies designed to reverse aging? I genuinely want to know. Share this with someone who loves space. And I'll see you in the next one.